All right, guys, we've spent the whole time on distance learning doing linear regression and correlation. Now we're going to take a day or two and do non-linear regression. I think you'll find this even easier because we're not going to go as deep into it, but you do need to know there are some regressions out there that are not linear. Look what I did with that title page. Do you see what I did there? Non-linear? Yeah, it's kind of linear though. I don't know. Let's go. It's Friday. Can't have a Friday without this. So take a sec, read through it. Happy Friday. All right, three basic rules for identifying a good mathematical model. Number one, look for a pattern in the graph. That's what we're going to do first. We're going to do a scatter plot, see what kind of pattern the graph has compared to what kind of regression we're looking for. Number two, find and compare values of r squared. We're going to find r squared. The better the r squared, the larger the values of r squared, the functions, it shows us which functions are better fit, whether it be linear or quadratic or cubic or whatever. The better r squared, the better the fit. And lastly, think about this. Think. Use common sense. Don't use a model that leads to predictive values known to be totally unrealistic. So sorry about that. Even when you're quarantined, you have to think. So, is what it is. All right, here's the main models we're going to look at. We're going to look at 5 of them. Linear we've looked at forever since you've been at home. Quadratic, you know what quadratic looks like, x squared. Logarithmic, which is kind of what this pandemic is doing. That's actually called logistic regression, but logarithmic is close. Exponential, some people are calling this an exponential growth of the coronavirus, and it is for a season, but then it kind of turns into logarithmic. Power, it looks similar to all these. So what we're going to do is we're going to basically use those 5 and figure out which one best fits our data. And the calculator is going to tell you which one, thank goodness. So you're going to use your calculator a lot, but it's better than doing everything by hand. So here we go. On your calculator, here's the big button you're going to use the most. All right, you're going to go to stat, like we always do. So I took a picture of mine. This is stat. And in the past, we've been doing tests all the time. But for today and probably a couple of days, we're going to just go to calc. And calc, look what it says right there. Linear regression, quadratic regression, quartic regression. That's LNREG is logarithmic regression, exponential regression. And if you scroll down, you're going to find power regression. They're all there. So it's under stat, calc. And that's the main thing we're going to use on the calculator. So make sure you might want to stop this and find that right now. Okay, and the rest of the calculator, you need to set this up because your calculator was not set to give you r squared. All right, so please, please, please get your calculator right now, pause the video, and then go through these steps with me, because if you don't, you're not going to be able to find your r squared. First thing you got to do is you got to go to catalog. Your catalog button is right above your, I'm trying to find it online, it's right above your 0. So if you look right above your 0, it says catalog. You're going to go there, and it's going to come up. Then when you do that, I want you to do this. I want you to hit alpha. Your alpha button is the green button. I want you to hit alpha D. Alpha. Misspelled alpha. Alpha D. And you may have to hit it 2 times. If you go alpha D, it will take you to the D's. And what you want is this one. You want diagnostic on. So that little arrow right there, little cursor, needs to be pointing at diagnostic on. Once it does that, hit enter, and it will come up like this. And I'll ask you to hit enter again, hit done. Once you see done and diagnostics on, every time you do one of these, you're going to get your r squared. You have to do those steps or your calculator is not going to help you. All right, so make sure you do that. All right. Linear, I'm going to show you what the graphs look like. If you see a scatter plot that looks very linear, obviously it's probably going to be linear. It's going to be your best fit. Quadratic looks like a parabola, and to be honest with you, even if you see half of a parabola, if part's not there and you see half of one, it could still be quadratic. You may just be seeing just half the parabola, which is okay. That could still be quadratic being your best fit. Logarithmic usually looks like this. This is what I was telling you about. A lot of the pandemic's kind of in this. It grows, then kind of flattens out. You've been hearing a lot lately about flatten the curve. That's why. And this is what the function looks like. All right. So when you write this down for your homework or for your assignment, which is homework because we're at home, that's what it's going to look like. 1 plus something natural log x. Remember, I hope you remember that from your algebra classes or pre-cal or wherever you came from. Exponential is quick growth. A lot of people say, the coronavirus right now is growing exponentially, which it is. it grows up, 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 and then eventually it will flatten out, which causes it to be called logistic, but we're not going there. Exponential. And the last one is power. Power looks, looks pretty similar to a couple of the others. So, but it is different, and the power being the x is not the exponent. The last one, exponential, the x was the exponent. If it's a power regression, the x is the base instead. So that's the difference in the two. And if you notice, this looks like, power could, if it's x squared, it's going to look like a quadratic. So you're going to have to really depend on your calculator and your r squares to figure out which one they want you to use. All right, I'm going to show you one example, and then we're going to stop for the day. The table lists below this population of the United States for different years. Find a mathematical model for population size, then predict the size in the year 2020. Okay, so here's the year. We started this year. We're calling 1900 or 1800 year 1, year 2000 year 11. So we're going in, basically decades. And here's what's happened to the populations. These are in, well, it doesn't really say what millions, I guess. Yeah, millions, 201 million right now, or 2000. And look how it's grown. Now you can't tell by looking, is it growing linearly? It does. I can tell it's not doing that, because it's going up by 5 million, 7 million, 14, 20, 19 to 20. So it's not the same every time. So that means it's not linear. So it's going to be one of the other ones. All right. So let's see what happens. So what I'm going to do is I punched it in my calculator. Those L1, L2, get my scatter plot. I'm looking at my scatter plot. That's obviously not linear, so I can narrow it down to 3 things. I can narrow it down to quadratic, exponential, and power. And so what I do is I take each one of those and punching in, like I do a quad reg, I do an exp reg, I do a power reg, and it gives me 2 pieces of information. It gives me r squared if you turn your diagnostic on, and it also gives you the equation. See on the top of that, it gives you the equation to write down. And because the quadratic was the biggest r squared, that means the quadratic is the best model. Whatever gives you the best r squared, the biggest r squared is the best model. So I'm going to use that equation right there. That's the best equation to fit the scatter plot. All right, based on its r squared, the quadratic model is best. So to find out what it is in 2020, I'm going to substitute x as 12. Remember, the years are going 1, 2, 3, and they all counted as 10 years. So I'm going to plug the 12 in for the x and both x's, all right, because it was quadratic. And I'm using the equation we saw on the last slide. I punched all that in my calculator, and I get 337 million in 2020. So that's the best prediction I can make based on the growth. And again, it was quadratic growth, which is not something people would normally guess what kind of growth our population has had. All right, your assignment will be on a Google Doc. It won't be very long, so knock that out, turn it in. Please turn it in before 9 o'clock. And have a great weekend. And we'll pick back up again Monday. Thanks for a good week. See ya.